In this video, I'll be discussing an advanced divisibility problem. Suppose that u and v are both integers, and u squared plus uv plus v squared is divisible by 9. Prove that u and v are both divisible by 3. So, to do this problem, we can first alter the form of u squared plus uv plus v squared. From the problem conditions, we can get that 9 is a factor of u squared plus uv plus v squared. And then we can change u squared plus uv plus v squared into u minus v squared plus 3v. You may wonder, why are we changing this into u minus v squared instead of u plus v squared? Well, notice that if you do u plus v squared, then you will get that you have to subtract uv. But then uv getting subtracted does not help because we want to prove that u and v are divisible by 3. And it's going to be easier to manipulate if you change it into u minus v squared because we get a factor of 3, which is plus 3uv. So, what do we do now? We can also get that 3 is going to be a factor of u minus v squared plus 3uv. This is obvious because 3 is a factor of 9. And since 3uv is a multiple of 3, this means that by the properties of the advanced divisibility, u minus v squared is also a multiple of 3. So 3 is a factor of u minus v squared. And we can also write down that 3 is a factor of 3uv. Next, we can get that 3 is going to be a factor of u minus v. This is obvious because since u minus v squared is a multiple of 3, then u minus v also has to be a multiple of 3. And this means that 9 is going to be a factor of u minus v squared. Since 9 is a factor of 3uv, so that means that 3 is a factor of u times v. And now, how do we proceed? We can assume that u equals to 3k, where k is an integer. So then we can get that 3 is a factor of 3k minus v. And since 3k is a multiple of 3, we can get that 3 is a factor of v. Similarly, we can then get that 3 is going to be a factor of u. And this is how we complete the proof.